Oh, hi there. I was thinking about solving exponential equations. You know, like you do. We wrapped up talking about properties of logarithms in our last video. I wanted to take a look at how we can use this in some applications and how it helps us actually isolate variables that are trapped inside exponents. You may recall we had one example that was a little unwieldy when we were just working through the raw, logarithm into exponential translation. There actually is another process we can use to tackle stuff like that that's a little more straightforward, I think. A bit more of a step-by-step deal. I've laid out that process in the notes handout that I have posted in Moodle. As usual, I'm taking for granted you've got that handy while you're going through this because I'm going to keep referencing examples and stuff that are in there. So the big thing about that process, we're going to end up taking a logarithm at some point in just about every problem of this nature. It's kind of, in there, if your variable's in an exponent, you probably need a logarithm to get to it. The big thing you need to remember, and it's the very first step in that process I gave you, is get that exponential expression by itself first. I've had some students who end up struggling with that. They'll end up replacing the exponential with some other variable, like a capital E for exponential, and then just putting in the exponential expression again later. If you're okay with moving it around on your own, that's great. Don't worry about that. But I'm just trying to suggest something that may help if you end up struggling with this. So let's take a look at this in the context of a few examples from the notes. So the first guy we have looks like this. So we have 5 to the 3x equals the totally natural number 823,542. Natural, right? So we don't really need to isolate the exponential in this instance. That's already taken care of. So next step, we're going to apply a logarithm so we can pull the variable out of the exponent. So standard algebra stuff, if you do something to one side of the equation, you've got to do it to the other. You could use any logarithm you like. I like the natural log because, like I said, I'm a math teacher. That's the one that really is natural to me. So we have ln 5 to the 3x, and again, whatever you do to one side, you got to do to the other. Now, great, we've taken a logarithm. Fantastic. What does that do for us? If you'll recall from the previous section, when we take a logarithm, our properties say an exponent living inside one of these guys, we can yank it out front as a coefficient. So we got this now. Now we don't have x stuck up inside the exponent. We can get it by itself with the same algebra moves we're used to. Again, keep in mind, ln of 5 is a number. It's a weird number. Ln of this, also a number, still maybe kind of awkward, but x is the only variable at this point. It's the only thing we don't know, so we can get it by itself. Divide both sides by 3, divide both sides by the natural log of 5. I'm going to do that at once. If you want to do it in 2 stages, that's fine. 8, 2, 3, 5, 4, 2. Again, if you do things all at once like I've done here, make sure you put that in parentheses as you enter it into your calculator, or else it'll divide by 3 and then think you want to multiply by the natural log of 5. That's not what you want to do. So you work through this guy, and accurate to 3 decimal places, I got 4.232. So that's the process without having to worry about isolating the exponential. The next few examples, we've got to do some work to get the exponential by itself first. It's okay, we'll walk through some of them. So example 2, it's kind of a one-step thing. I'm actually going to leave that for you to take a look at on your own, and we're going to take a look at the next 2 because they're a little more involved. So example 3, we have 5 equals 6 minus 6. This time around, we've got that funny E number living in our calculation. Do note inside the PDF, there is a decimal point right there. I like writing zeros in front of them just to make sure I don't lose the decimal point because, you see my handwriting, right? So we've got to get this guy by himself first. As I said, if you want to replace this with some other letter or symbol, some folks I've had who are really intimidated with algebra will just draw like a smiley face. I don't think you need to do it, but it's available. So we got to get this guy by himself first. So we've got to do usual algebra type stuff before we can apply that logarithm here. So I'm going to subtract 6 from both sides. So that goes away. So now I have -6 plus 5, or 5 minus 6, however you write it. You can just go ahead and collapse it down to -1. That's also fine. Now I need to get rid of this -6 hovering around in front of the exponential. So I have -1 divided by -6. Almost lost my minus sign there. That would have thrown things off. And we have now e to the -0.04x is by his lonesome. That's what we're after. And again, the negatives cancel. You can write that as 1/6 if you like. So now I take my natural log of both sides. Again, whatever you do to one side, gotta do to the other. And this is part of why I like the natural log. You'll notice a lot of these examples end up having this funny number e floating around. And if you think back to last time, we don't even really need to worry about the exponent hop out front property. You can do it if you'd like, but we saw those inverse properties. This is a base e logarithm. We have a base e exponential. They cancel each other out. So all we're left with is the juicy -0.04x that was in the exponent. So we've just about got x by itself already. We don't have to do any more fancy maneuvering. So just divide both sides by -0.04. If you'd worked out the natural log of 1/6 already, that's okay. Shouldn't throw things off so long as you don't like cut off your rounding too early or anything like that. So I got 44.794 accurate to 3 places. So done. All right. 2 examples down, 1 more to go that I want to take a look at, and this one can end up looking a bit more intimidating. So I want to make sure we're all on the same page here. So this last guy, well, 3 on the left-hand side doesn't look that scary. It's the thing on the right that might kind of freak you out. So we have 4 divided by 1 plus 30 times e to the -0.3x. Yikes. That even gives me a bit of the shivers. So my move here, there's a couple of different ways you can do it. That's one of those weird math things that you can sometimes lose track of. There's often many roads that end up leading to a solution. What I'm going to do here is basically flip over both sides of this equation. The fancy verb for that is reciprocate if you like. If you don't like, it's okay. You can just say flip it over. I'm okay with that. So flipping over the left side gives me 1/3. Now, that bottom, which was kind of creepy looking, is now in the top. I mean, maybe it's still creepy looking, but at least it's not the bottom of a fraction. The bottom is now just 4. That's a number, we can get rid of it by multiplication, same way we've been doing. Multiply by 4. Get out! Over there, we'd have 4 times 1/3. I'm going to write that as 4/3 going forward. But now that's gone, and we can proceed with getting x by itself just like, or e to the, as you said, the exponential rather, get it by itself just like we did in the previous example. So I'm short on board space, so I have 4/3. I'm going to need to subtract this 1 over. He's gone. Now all that's left to get the exponential by itself, I divide both sides by 30. You can work out the arithmetic here. If you had a decimal, it's okay, but it turns out that you get a 1/3 up top. 1/3 divided by 30 is 1/90th. Just rolls off the tongue, 1/90th. So now, just like in the last example, we take a natural log. That's conveniently going to get this e out of the way and just leave us with the exponent, which is the thing we were after. So So we got that guy right there. Again, whatever you do to one side, got to do to the other. The inverse property, these conveniently see each other clear off the board. So we divide both sides by negative 0.3. And you crank that puppy out, 14.999. The 9 stop at that point. It would have ended up rounding up to 15.000 if it hadn't. So there's some examples. At the moment, they are delightfully free of any real-world application. I just dropped an equation in front of you and said, here's this thing. Get x by itself in the thing. I mean, that's okay. It's good for practice. So we're going to take a look at some more examples of this in action going forward that actually do draw from some real-world context. Before I move on to the next video, I do want to point out something. Be very careful with rounding stuff off here. My rule of thumb is I don't round until I absolutely have to. I mean, you notice I've just been writing ln of 1/90th. I've been putting that into my calculator when I go about getting my solutions for these things. In general, if you start trying to round things off, keep more decimal places than you think you're actually going to need for the final answer, especially if you end up with something that's really small and has a lot of zeros in front of it. Yeah, turning something off, yeah, that can really mess things up in this context. So we're going to take a look at some applied examples next time, so stay tuned.